Hello, my name is Alesandro, and this is my lab presentations for Lab1 charge tapes. So, the goals of this lab. We're going to prepare two pieces of charge tape. We're then going to observe and record interactions between the charge tape and another piece of charge tape, as well as other objects. We're going to then determine the excess charge on the tape, and we're also going to use GlowScript to basically use the code we did in Lab 0 to then calculate some of our results. Purpose of this lab is to, as I said, determine the excess charge on charge tape, and then we can apply that knowledge to estimating the excess charge on a lot of different everyday items. So a preview of our results, the charge tape ends up having a net positive charge. The charge on the tape, as we'll see later in data and conclusions, is 1.196 times 10 to the negative 8. The tape has a total of 7.476 times 10 to the 10th electrons, and the sticky side of the tape has 3.99 times 10 to the 17th atoms. Key concepts, we know gravitational force, F equals mass times 9.81, and we know Coulomb's law, which is K, Q1, Q2 divided by R squared, with K 9 times 10 to the 9th. So, assumptions. The piece of the tape acts as a point, which basically is a point charge located at the center of the tape. This is for purposes of modeling as point charges, making easier calculations. We also assume that both tapes have the same amount of charge, also for data and conclusions. Procedure outline, we're going to create a U-tape. Basically, you take a tape about 8 inches long, fold one edge down, stick it to a smooth surface. You'll stick another piece of tape, making it the same way with a handle, etc. Write U on it to remind yourself, optionally. You're going to quickly pull that tape off, hang it from your desk. You're going to notice it's charged because it's attracted to your hand. Two interacting U-tapes do the same exact thing. Observe what happens between them. To make a floating U-tape, just observe this diagram and kind of just do exactly what it's doing. Interactions and observations. So the U-tape and my hand attracted. The two U-tapes repelled, being that they have the same charge. The U-tape and the pen did attract to each other. To create this charged pen idea, you rub the plastic pen. I rubbed it on my shirt, became negatively charged, and therefore the U-tape is positively charged. So going back to what we just saw on the previous slide, when we make the floating one, they repelled, as we saw above. They both repel, and there was a separation distance of 0.025. Data and conclusions. So the gravitational force we would find by calculating the tape weight, which we did the length of the tape, which was 0.21 meters, multiplied that by 0.001 kilograms, multiplied that by 9.81, in which we got 0.0020601 newtons. To find the charge on tape B, we wanted to say gravitational force equals electric force. This is because the net force equals 0. So then we use F equals Q times electric field, find that the charge on the tape would be 1.196 times 10 to the negative 8th coulomb. So then, to calculate the number of electrons, we would literally just divide the charge divided by the charge of an electron, in which you'll get 7.476 times 10 to the 10th power. So then, lastly, to find the number of atoms on the sticky surface of the tape, we would literally just take the surface area and divide that by the area of the atom. So we would do length times width divided by area of the atom, in which you get 3.99 times 10 to the 17th, and you can see the calculations with numbers below. So answering these last questions, what if electrons had a positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? Well, if electrons and protons switch charges, the positively charged U-tape would become negative and have an electric field that points up toward the tape rather than the other way. However, while the charges are opposite, none of the observations would change. The two U-tapes would now just have equal negative charges, still resulting in repulsion, and the charged pen would simply have a positive charge instead, resulting in the same observation as before. Now, why is it important to handle the charged tapes as little as possible? So, we know contact could lead to a transfer of electrons. Therefore, touching the U-tape would result in a transfer of surface electrons and therefore a transfer of charge. Therefore, the U-tape would gain electrons from our hands and have a lesser positive charge. Thank you so much for your time. Have a great rest of your day or night.